Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between online inference to batch inference. Latency requirement. Online inference very low millisecond to few second to provide a response while a user wait. Batch inferences high latency hours or days is acceptable run on a scheduled data flow. Online inference data flow single or a small micro batch of data for a single prediction request. Example, one user click. Batch inference large accumulated batch of the data processed at a scheduled time. Deployment architecture. Online inference requires a highly available web services REST API or serverless functions to handle concurrent request. Batch inference requires a scheduled job, example cron job, Airflow, DAG running on the distributed computing framework, example Spark. Feature fairness, freshness. Online inference features must be as fresh as possible, uh, example based on the last few seconds of user activity. Batch inferences features can be installed, example calculated daily or hourly resource uses. Online inference to consist low to moderate resource usage over time. Batch inference high rusty resources usage during the scheduled batch run. Use case online inference real-time prediction, example dynamic pricing, fraud detection, recommendation engine serving a single user. Batch inference bulk prediction, example lead scoring for the CRM data base, product inventory forecasting, calculating yearly customer churn. Cost driver. Online inference primarily the cost of running the always on serving infrastructure and handling peak traffic. Batch inference primarily the cost of the large compute job, example large cluster size in Spark. Error handling. Online inference must fail gracefully and quickly for the user. Example, returning a default safe prediction in batch prediction can be retired and monitored extensive without user impact. Moving to question difference between principal component analysis PCA and linear discriminant analysis LDA. Learning paradigm. PCA unsupervised dimensionality reduction. LDA is a supervised dimensionality reduction. Primary goal PCA to find the direction components that maximize the overall variance of the data. Uh, in LDA to find the direction component that maximize the separation between different classes. Information used. PCA use only the feature data. X ignores the class labels. Y. LDA uses both feature data and class label data projection. PCA projects data into low dimensional subspace that preserve global data structure. LDA projects data into lower dimension subspace that optimize class discriminability. Maximum components. PCA maximum number of component in is min n minus 1 d, where n is the sample and d is the feature. In LDA maximum number of component is min c minus 1 d, where c is the number of classes. Data distribution. PCA does not assume any specific distribution for the data. LDA assume that the classes share the same covariance matrix and that data is Gaussian distributed, often violated in practice. Use cases. PCA generally dimensional reduction for visualization, noise reduction, and speeding up unsupervised learning. LDA feature extraction specifically for classification tasks to improve model separation terminology. PCA improved component are called principal component. LDA components are called discriminant function or linear discrimination. Linear discrimination. Please like, subscribe the channel. Thank you.